It says, there are two corrections to the ideal gas law that are factored into the van der Waals equation. What are the two corrections? What is the reason for each correction? Under what conditions is each correction most noticeable, and why? So there are two things that in the ideal gas law that have to be accounted for. And the first is the volume correction. The ideal gas law assumes that the gas has no volume. Said another way, the molecules themselves have zero volume. What does have volume is the space between the molecules. Said another way, the volume of the gas is completely empty space. The molecules themselves have no volume. And under normal conditions, this is relatively true because the relative amount of space taken up by the molecules themselves relative to the space between them is insignificant. So the reason for the correction is that molecules actually do take up space. When is this most noticeable? This is going to be most noticeable at very, very high pressures. Why is it going to be noticeable at high pressures? Because at high pressures, you're cramming those molecules together. Said another way, you're decreasing the amount of empty space. If there's less empty space, the volume of the molecule itself relative to the empty space is going to be much smaller. So you have access to this, so I'm not going to write all this out, but that's basically how it works. The second correction is the molecular attraction correction. Now, in this ideal gas, we assume that we have perfectly elastic collisions, which means there's no attraction between the molecules. When they hit together, they bounce off with the same amount of energy that they came in with. They don't have any tendency to stick together. But in real life, that's not true. Molecules do tend to want to stick together, all right, which is probably a good thing, but they do want to stick together because of intermolecular forces, which you cover in the next chapter. When is this going to be most noticeable? This is going to be most noticeable at low temperatures. Why is it most noticeable at low temperatures? Because in that case, the molecules have the least amount of kinetic energy. Therefore, at low temperatures, when the molecules interact with each other with a lower energy, the relative amount of energy of the attractive force becomes greater. Just like in the volume correction, at high pressure, the volume of a molecule matters more because there's less space. At low temperature, the attraction becomes more noticeable because there's less energy. So that attractive energy between the molecules becomes more noticeable. Or another way of thinking about it is at lower speeds and lower kinetic energies, the molecules have more time to interact with each other and stick together, or more opportunity to do so. So I hope that that helps, and here are the actual answers, but I thought I'd give you a brief explanation.